Hello, everyone. Here's some bunch of problems, just a lot of limit problems, but without L'Hopital. Later, after we do some things with L'Hopital, a lot of these can be done using that. People think L'Hopital is always easier, and it's not. Sometimes it is, sometimes it's not. Okay, so we're really based on like a flow chart of things. When you go to a number, definitely plug in and see what you get. If you do get a number, that's probably your answer, but there are sometimes domain issues because limits must have both a left and a right. If you get a number over 0, you know you're at an asymptote, and you should analyze the signs to figure out which of those three you have. And if it's 0 over 0, or even there's some other forms, infinity minus infinity, you have to worry about that it's indeterminate, and you have to do something, often algebraically, conjugates, factoring, things like that. If you're going to infinity, well, there's some functions that you should know that either will grow infinitely, like in here, and that's when the top dominates. If you have an f over g, if the f function dominates the bottom function, then it'll either be infinity or negative infinity. If the bottom dominates, then it goes to 0. And if they're the same, then you'll be able to figure out a number by crossing out insignificant things, but just realize it might be that number or its opposite. All right, so here we're going to infinity, and I realize that these are the same. And here's the question. Usually that dominates, but not a negative infinity. 4 to the negative infinity is 0. Here, this is insignificant. And what we're left with is x over 2x, which simplifies to 1/2. And with the square roots, I'm kind of worried. Maybe I screwed up the signs. I noticed that the bottom is negative for sure, and the top is positive for sure. So it really isn't 1/2. The answer would be negative 1/2. Okay, here's pi over 4. This looks like, I bet you we can just plug in. Here we'll get sine of pi over 2 plus cosine of pi over 4 all over, looks like 4 times pi over 4 is pi. All right, what's sine of pi over 2? I think that's just 1. And what's cosine of pi over 4? That's just going to be root 2 over 2. So we have 1 plus root 2 over 2 all over pi. You should never have fractions inside of fractions unless the thing's so complicated that it's not smart to try to simplify. So if I multiply everything by 2, I'll have 2 plus root 2 over pi. Going to infinity, we're going to compare things here. The degree up here is 7/3. Once again, this is insignificant because it goes to 2 to negative infinity. And on the bottom, I have 2. All right, that looks like the top it dominates, so it's either going to be infinity or negative infinity. A negative raised to an odd exponent, or odd over odd, will be negative on top and positive on the bottom because of this x squared. And so we are going to say negative infinity is my answer. Here we're going to a number. Cosine of 3 pi, cosine of 3 pi, let's see, pi, 2 pi, 3 pi, cosine, so that's just negative 1, and e to the 0 minus 1, okay, and then on the bottom we have 0. So we really have negative 2 over 0, and the possibilities there are infinity, negative infinity does not exist, and because of these absolute values, the bottom is always positive, and we're going to choose negative infinity. All right, maybe we can do this problem just by part, and at infinity, this one fraction just turns out to be 1, right? Because we have degree 1 over degree 1, and if this is insignificant, you'll have positive over positive. So that, and then we're going to minus cosine of pi plus Any number over infinity is 0, so pi is 0. So we really have 1 minus cosine of pi. I think we did that one before. Cosine pi is pi, yeah, over here. And cosine is -1. So you have 1 minus a -1. That's going to come out to be 2. All right, lots of stuff here. I bet you it's going to, it's in factored form. That's awesome. We'd like it that way. 3 minus a -4, that's 7. -4 plus 1 is -3 to the third is -27. Don't multiply it out. Here we have -4, and down here we have 0. And so this is going to be a number over 0. We're going to choose between these 3. And if I notice this is the only factor that matters. Positive, negative, negative. This is actually positive because of the even exponent. And so we'll choose positive infinity. Plugging in 3, I get 3 minus, I think that's 27 on top. And on the bottom, I get 9 minus 18 plus 9. So I do get a number over 0. All right, so our choices are between infinity, negative infinity does not exist. And here's an important one here. I don't care about the top because we know the top is -24. But the bottom is a perfect square trinomial. And if you factor it, you'll see that it's a perfect square. And so the bottom is positive. And so we'll choose negative infinity as an answer here. All right, going to 0. This is infinity, and this is 0. This is infinity times 0. That's indeterminate. We have to do something. So, you know, there's just too messy here. Anything can happen. I think we'll need to do some simplifying. And if the common denominator of the inside of the parentheses is 4 times 4 plus x, then I think I have a 4 minus, now when you multiply with 4 plus, these in parentheses, very important, and what we're left with is 1 over x, okay, no need to change this, so just make that 4 plus x, and the 4 minus 4 is cancel out, but we have a negative x on top, and thankfully the x's cancel out. I guess I'll make it 16 plus 4x. And now if I go to 0, I'll get -1 over 16. Notice how little of like plugging in 3.99 and 4.01 doing. You can do a lot without actually plugging it in. All right, so piecewise, if I'm going to 3, then I care about the dividing point. It doesn't matter that there's no or equal to, right? The point doesn't exist, but we can still plug in. And so on the left side, we care about 3 ln of 3. On the right side, we care about ln of 3 times 3 is 9. Okay, maybe they're the same. Let's think. I know I can bring this up to the top here. So that's really ln of 27. This one's ln of 9. This one does not exist. They are not the same. All right. Here, you know, don't automatically go to conjugates, right? This looks like a conjugates problem, but maybe it's not, because when we go to infinity, we care about the degree. Insignificant, square root of x squared is just x. On the bottom, we have 36x. And so my answer is either going to be 1 over 36 or -1 over 36, based on the sign. And if I'm at negative infinity, the bottom is negative. And this is all positive, but it's going to be 36 minus this. So I think we have negative over negative, and we'll have a final answer of 1 over 36. Once again, it looks like conjugates, but right, make sure you know the process. When you're going to infinity, this is insignificant. Here's another one where it's insignificant. I guess I did too many here, because I should have a couple where 2 to the x is dominates everything and would be. But here's another case where 4 to the negative is insignificant. And what do we really have? We really haven't. Square root of x squared is x. Now, square root of 5 is square root of 5. So that's not, there's no way to simplify that. And so we're choosing between root 5 over 4 and negative root 5 over 4. And at negative infinity, I notice the bottom is negative. And this square root thing is going to be positive. And so my final answer is that. Here's another one, infinity. Very similar. We care about the degree. There's just going to be a lot of negatives going on. I think. Let's check the degree. The cube root of 27x to the 9th is 3x to the 3rd. And down here is 4x to the 3rd. So we will be choosing between 3/4 and negative 3/4. The bottom is positive. All right, a lot going on here. Odd exponents means this can be negative. When I plug in infinity, this will still be positive. So it's going to be 0 or insignificant minus infinity. So negative on top. And so the answer is going to be negative 3/4. All right. This looks like a kind of a AP Calc type problem. Which of the following statements are true about f? So what's going on here? It's important to know. Maybe I sketch it out a little bit. 3 minus x squared looks like this. 2 minus x, 2 I think would be like a line with a hole here, and root, when I plug in 2, I think it's the fill. I think it's going to get filled in. So just to start, we'll check each time. So the limit as x goes to 0 of this function. If I plug in 0, I get 3. When I plug in 0, I get 2. So the limit does not exist. The limit as x goes to 2 at 0. Now I care about here and here. When I plug in, limit as x goes to 2. Wrong spot. As x goes to 2, I'm going to plug in here. 2 minus 2 is 0. All right. And from the right, 2 minus 2 is also 0. So that does exist, right? Square it's okay because you're only plugging in 2.01. And limit as x goes to 1 equals the limit as x goes to 6. Now 1 is in the middle. You can just plug in here and you get 1. And when you go into limit as x goes to 6, that means you're on this branch. So just plug in there, square root of 6 minus 2. No, that's not true. I think 2 only. All right, and then one last challenging one. This is 0 minus 0, I think, no. If I plug in 2, ooh, okay. This looked like a different thing. All right, let's be careful. Let's plug in from the left and the right because of this square root of 0 thing. And I'm not sure. This looks a little weird. All right, so when I plug in a number a little bit bigger than 2, this will be bigger than 4, and so there's no domain problems. So we'll have 0 minus 2 equals negative 2. All right, but what happens when I plug in 1.99? Okay, this is smaller than 4, and this is going to be a domain issue. This does not exist. So by the definition that we're currently using in AP Calc, the 3-part definition, there is no left side, and you'd want to say does not exist as a final answer. All right, lots of good problems. Good luck to everybody.